All right. Good morning, everyone. My name is Anna Holder. I am the Open Data Science Equity and Tribal Coordinator in OEMA. My pronouns are she, her, and I'm going to be one of your MCs today. I'm here for backup logistical support. As you join, we recommend you get yourself situated so you can engage with us for the next 2 hours. That might include closing your emails. As hard as that is, we highly recommend it. Getting your monitor set up in a way where you can see the slides, and maybe your R studio is set up if you want to code along with us. I'll share a link to the slides in just a second so folks can copy code as it comes up. We invite you to turn on your cameras. We love to see your beautiful faces, and it really stinks looking into the void for 2 hours. But if you just can't do that, you're not feeling it, logistics, whatever, we totally understand. For now, we're gonna welcome folks to add questions to the chat, like as they pop into your head, until we invite folks to speak, and there'll be little moments to do that in breakout rooms and things like that. And I think with that, I've started the recording. I said all the things. If you haven't already, please introduce yourself in the chat, name, pronouns, if that's something you like to share, your region, division, or office, and the snack that's been giving you life in recent times. So as folks are doing that, I'm going to pass it over to our instructor, who's going to lead us through this training today and next week. And we're really excited. Hannah, take it away.
Hello, everybody. Thank you so much for joining us this morning, taking some time out of your busy schedule to think a bit more about data and equity. I am so tempted by all of the snacks. It's 11:30 here where I am in Chicago, so I'm excited to try some of these things out. But yeah, I guess I'll start with a quick introduction of myself, and then we can go ahead and get into the material. So as I mentioned, my name's Hannah Cushman-Garland. I'm a partner at a small data and web consultancy called DataMade. We have engaged with the water boards for going on 5 years now. It seems like we started working together during the pandemic on the COVID wastewater surveillance. And in the last 18 months, we've been working together on just some like coaching around data and using data and through the lens of like racial equity. So I may have met some of you individually, and if I haven't, great to meet you. And yeah, really excited to go through this today. I guess in the spirit too of being a whole person, besides doing data work, my favorite activities at the moment are riding my bike all over Chicago, which is flat, which is amazing. Chasing my toddler around / eating his snacks, and knitting toddler-sized things, which is so much faster than knitting adult-sized things. But yeah, let's go ahead and get into it. So let's see. Anna, can you confirm we're seeing the slides as expected?
Yes, everything looks good. If you want to advance, so we can
Super.
check. Perfect.
Cool.
Rock and roll.
Super. So welcome to module 1 of 2. And in this module, we're going to be focusing on identifying injustice and how data can help us do that. So before we get started, I wanted to follow a recommendation from the handbook, which is that it's important to establish some common language when we're talking about equity, just so we're all on the same page. Some of these things can feel really squishy or nebulous. And in fact, you can define equity based on, the context that you're working in. And so we're going to set a working definition for the purposes of this module. So the water boards conveniently actually has language about what equity is, what racial equity is, and it's a series of conditions. So first, race no longer predicts a person's access to water or the quality of resources they receive. 2, race doesn't predict professional outcomes for employees. So that's the more internal facing versus the external facing. That is the first point. And then the third point is consistently considering racial equity impacts before we make decisions. And this is the one we're really gonna kind of hone in on today. racial equity is a practice, right? It's not a destination. It's not we achieved it and we're done. It's a series of decision or like a framework for decision making that you can continually engage in and refine based on, the results of actions that you take. So I just wanted to kind of ground that a bit more in our working reality before we move forward. So let's see. So we've talked about what equity looks like. What does inequity look like? Um, if our working definition is a future where race no longer predicts a person's access to resources or water, then it follows that inequity is a difference in disparity, or a difference or disparity in access or resources. So, like I mentioned before, equity or inequity can really vary depending on like the problem that you're looking at. But this is going to be our baseline. Is basically we're looking for um, access, equal access to resources, and no disparate exposure to harm. You can adjust this according to your needs as you kind of work with these considerations in mind. Great. So why are we interested in disparities? Difference in exposure to harm or access could represent injustice, which we're really going to double click on today to use the lingo. Um, so our difference could represent injustice, and disparate outcomes can also give us some hints on what is actually at the root of that injustice. Not just, we want to kind of get beyond thinking about the side effects, which is, kind of just looking at like one layer of the issue. And we want to start to think about, what is the thing that is actually causing these side effects? And then like maybe even what is the thing that's causing the thing that's causing these side effects? So injustice can help hint at some of those underlying layers. And why are we interested in getting at those underlying layers, what we're calling mechanisms of injustice for the purposes of this session? So we're interested because actually understanding like the root cause or causes can help us contemplate effective interventions. We don't want to just arrive at the water-shaped Band-Aid without kind of an awareness of how what we're doing fits into that broader mosaic of conditions and things in history that lead to disparities. It also allows us to start to identify other places where that cause or those causes or mechanisms are also at work. So in that way, it can help us also find other places that might benefit from the intervention that we're applying in a particular place. So it can be a way to help scale in a principled way. So with all of those things in mind, we're going to do a little exercise where we look at a real water system in California and start to think about who is affected. So we drew this example. This is about Lamont. The SAFER program gave 25 million in 2024, I believe, to help fix their failing water system, which had 3 wells exceeding the MCL or maximum contaminant level of arsenic and 1,2,3 trichloropropane. You'll also notice throughout the slides, this is just kind of a housekeeping point, but anything that's kind of like complementary information, you can access like linked along the bottom here. So there's a lot of links to extra stuff as you're diving in here on your own that you may find helpful. So back to our exercise, we're going to be taking a look at Lamont, which had a failing water system. So as we look at Lamont, we have a lot of questions, right? Like we want to kind of get a sense of like what's going on here. We don't want to just we do obviously want to mitigate the failing water system, but we also want to think about, why was the water contaminated in the first place? Who was exposed to water from the system? Like who was using the public water system or other vectors of exposure? And also, are there racial disparities in who is exposed? Why? How does that work? This is our first stopping point here. Are there other sorts of like questions that folks have off the top of their head that they might pursue if they were faced with this question of a failing water system? And Anna, if there's anything, you can shout them out, or you can share in the chat. And if there's anything in the chat that you want to surface, please do chime in.
For us, it's an undesirable result for the Sustainable Groundwater Management Act. So that's one of the 6 undesirable results. So they can't have poor water quality.
Can you rephrase that in the form of a question for the interrogation?
Going Socratic method here.
I don't know. I didn't have coffee this morning.
Oh no.
What constituents have are exceeding MCLs, SMCLs,
Great.
or undesirable results.
Awesome. Madeline? What are you
Uh,
thinking?
yeah, I was thinking like if there is someone who benefits from the continued failure of this water system, because that can be really important if someone starts blocking the way to solving it, you know?
Yeah. Jeannie?
Yeah, I might look at, how old is the system? How, what are the maintenance records, or when was it last updated?
Nice. Someone in the chat, if you add something to the chat, I'm not gonna say your name so that you remain anonymous in the recording. So someone in the chat also contributed, how long has the system been failing? These are all really great questions, and we might get to some of them next. Hannah, do you want to keep going?
Sure. Yeah, these are really excellent questions. The first one too, this is one of the points of failure. It would also make me wonder, like, are there other points of failure that are affecting, or, is Lamont also experiencing other points of failure along that scale? Cool. So yeah, this is super great. Not great that it's failing, but the questions were great. Before we get into sort of diving into one of those questions, I wanted to make a quick note about the benefits of reproducible data analysis. So in these modules, we're going to be using R to write this code. But a lot of the approaches, like retrieving census data, making maps, are kind of common across programming languages and even software like Excel. You can make all kinds of charts in Google Sheets or Excel. You can make maps with a number of different like free online softwares, or if you are a GIS pro, an ArcGIS or QGIS if you want a free alternative. So yeah, I just wanted to explain a little bit about why that is. And the first one is easy, right? It allows us to automate and reproduce our analysis. So basically, we can run and rerun this. We can run it with different inputs. So we're going to look at Lamont today, but maybe there are other places that you want to do a similar analysis on. Packaging it up in an automatable format makes that possible. It also, and this isn't listed on the slide, but in the interest of transparency, it also makes clear, what analysis you did, how you did that analysis. And so if you were ever in a position where you wanted to make that sort of thing available, you could to constituents. In a little bit, we'll look at some EPA data, and they've actually got great patterns for sharing a lot of their analyses on GitHub. And that it's a valuable resource because there's the transparency element, but also people can reuse your work, build off of your work instead of repeating things over and over the same analysis. So it can lead to richer analyses kind of in the community of practice. And then this one is a little bit more of the moment. So hopefully for future viewers, this is less of a threat, but right now in the moment, we have seen some public data resources, particularly from the federal level become unavailable. So when we put this together, the EPA's environmental justice screen was offline. So today we're going to be working with lower level resources. So we'll be using the Census API rather than a web interface. And like the working theory is that they're kind of less visible, used by maybe fewer people, and so maybe lower priority for censoring. But it's basically, it kind of gives you a little bit of a backdoor to some data that may not be otherwise available. So without further ado, we are going to look into the question of who was exposed to the contaminated water. So the first thing we're going to do is just look at the census data and determine the race ethnicity of folks who lived in Lamont. So in R, we're going to use the Tidy Census package, which is really nice. If you're an R user, it plugs right into other Tidyverse packages. If you're not an R user, the Tidyverse is essentially kind of a little universe of R packages that has its own little vocabulary and syntax for working with data. An equivalent maybe in, say, Python could be like the pandas ecosystem or that sort of thing. And if you are not an R user, the coaching website, which we'll share out after this, includes some methods for retrieving census data with Python and also in the web browser. So we're trying to cover all our bases here, but our first exercise is going to be to retrieve some census data on race ethnicity in Lamont. So step one, shout out to Megan Kung, who pointed out that this was an important step and wanted to make sure we included it. But the first thing we're going to do if you don't already have one is to get a census API key. This is super easy. It's pretty much instantaneous. It's linked down below, or if you just Google like census API key requests, it will come up first. But you put in your email, put in your name, and they'll send you an API key, which you can then use in subsequent requests. But this is a very important step because if you can make some requests to the census API without a key, but I think the rate limits or like the number of times you can make requests is pretty small. So if you're going to be doing really any kind of analysis, I would recommend having a census API key. There's not necessarily a huge downside to it. And like I said, this should show up pretty much instantly in your inbox. So once we've done that, we can start putting together some R code to retrieve our census data. So when I'm retrieving census data, I think it's really useful to kind of define variables that have the important information. So first, we're defining where we want information for. So our state, county, Kern County, and then city, Lamont. I also think it's really nice to make a little mapping of the census variables that you want to use, which are like the P2005N. They're all kind of like this concoction of strings or concoction of like letters and numbers and underscores. And they can, if you glance at that, you don't know, oh, that's the white population. So it's nice to map those in some way to what they actually represent. So we've just created a little mapping here that maps each variable to the race ethnicity that it corresponds to. And then down below in the footer, I would definitely recommend if you are going to be using the Census API, the Census Bureau has a nice user guide. Census Reporter is also a great resource. I use it all the time. But you can search by geography or by topic. And the topic stuff is really nice because it will give you information about like how the census gets data about like race and ethnicity, how it gets data about families, how it gets data about income. It's just got a lot of great context in a super easy to like understand, user-friendly way that you don't always get from the census website, which is very good, but very thorough to maybe a detriment. Great, so we've defined where we want data from and what variables we want. So our next step will be where we use that API key we got earlier. So I've commented it out because I authenticated with my API key in a hidden code block earlier in the notebook here. But you'll see here on line 1, the Tidy Census API key is where you plug your key into, you run that, and then any requests you make will then be sent with your key moving forward. So that's a nice convenience function, super easy to use. The second thing we're going to do is use the Tidy Census package, specifically the get decennial method. to pull down the census data that we want. So we want the most recent decennial census in 2020. They're every 10 years. And we want the summary file. And then the next couple of lines are where we put in our state, county, and then the geography lets you specify which census geography resolution you want it at. So for our purposes, we're going to use blocks. There's blocks, block groups, tracts, and that goes up from there, but blocks are the smallest unit of geography. So we want to get granular. You'll see here on line 8, we're passing in that mapping we made of our variables that we want to retrieve. And the tidy census also has this great argument summary variable that you can retrieve with your data. So it will give you the value for the white population, for instance, and then like the total population. And that's really useful if you want to calculate proportions or do other computations involving like the total population or some other like summary variable. And then finally, this geometry equals true tells tidy census. In addition to the variable values, we also want the shapes of the blocks. So this is really useful for mapping. Basically, you can get everything in one call. You can get your shape, you can get your metadata and go to town. And then finally, on this last line, line 11, we'll mutate, which is a function from the tidyverse. And it basically means make a new column equal to whatever's inside the parentheses. So we're going to make a percent column that is the variable value over the summary value times 100 to give us a percentage of the population that each race ethnicity group represents in that particular block. So an important thing to note when you're pulling down census data is that at least through the tidy census package, what you get back is going to be tall data. You may have heard the phrases like tall data versus wide data. The essential definition is that tall data has kind of a row for every record, and wide data might collapse that up in some ways so that you have your organizing unit and then a column for all the variables you want. So by way of example, this is what we get back from tidy census, the tall version. And you can see for every block, so this is block blah, 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 1006. Here's the white variable and the value, and then the summary value, and then we have the percent here at the end. And then in the same block, we have another record for the black variable and the value and the summary value. On down. So for every block, we have a row for every variable. And that can work if that's the kind of analysis you want to do, but we want to look at this data by block. And so we want to take this tall data and reorient it. So we have one record for every block and one column for each block for each of the race and ethnicity groups. So luckily, there's a really easy way to do that. Pivot wider is another convenience function from the tidyverse. Note too that there's an equivalent but opposite method called pivot taller or pivot longer. You'll have to Google that one. It's one of the two. That'll take your wide data and make it tall, but we're taking our tall data and making it wide. So all we need to do is say, take our tall data, feed it to pivot wider and tell it names from is like what fields, which column in your tall data you want to expand out into columns in your wide data. So if you remember, we have this variable column that has white, Black, American Indian, Asian, so all of our race ethnicity groups. And this is saying, create a record for each block that has a column for white, Black, Native American, Asian, and on and on. And then our values from are which column to pull, like the tall or the wide data value from when we make it wider. So I think it'd be easier to just show you what the output is. So this makes a little more sense. But we have pivoted our table. So instead of having variable white value X, we now have a column for value white, value Black or value American Indian for all the race ethnicity groups. And then we also have like the percent for each of the race ethnicity groups. So hopefully now that makes a little more sense, where we say we want columns named after each of the variable names, and for each of those we want a column that is the value, variable name value, and variable name percent. Hopefully that is, as my high school calculus teacher would say, clear as Kool-Aid. But basically what we've got now is data that's by block, our number and percent of folks in each race and ethnicity group. So the last thing we need to do, if you remember, we only retrieved our census data for the county, Kern County in Lamont, and we need to filter it down to just Lamont. So we'll use our package called Tigris, which allows you to retrieve different census geographies, places, are another census geographies. So basically, we want our census places in California with blocks, census blocks included. And then we're going to use this filter function from the tidyverse to basically give us the census blocks in California where the name of the block is Lamont. So that gives us our census blocks in the city. And then finally, we can take our city blocks or our county blocks and our city boundary and do a geospatial join, which allows us to filter all of our blocks in the county to only the blocks that are within the city of Lamont. I hope I explained that like well enough. Anna, do you feel like that was clear enough?
Yeah, and I also just want to note that if you're trying to follow along with the code, you don't need to be typing all of the code. If you have the slides open, Hannah, can you hover over the right side of the code block?
Yeah.
If you do that, a little copy icon shows up, and so it enables you to copy the whole chunk of code and paste it into your R system. Should have said that sooner, but if you're not coding along with us, that's totally fine. Just absorb it all and do it later. Yeah. And since we paused, any questions so far, or anyone need clarification on what Hannah has just articulated? All right, dig in the clearest Kool-Aid. Let's keep it moving.
Super. All right. So now that we've got our block level data, for this portion of the exercise, we're going to further aggregate that up. So we want to just basically add up all the block values so we have overall numbers for the number of residents and the proportion of residents in each race and ethnicity group. So with this code, summarize is yet another function from the tidyverse. You begin to see that it is a whole suite of things that work together. But summarize is really nice because it's kind of like a way to roll up data into higher level aggregates. So we are asking for like the overall total population, and then for each of white, Black, and Hispanic populations, we want the sum of each block's number value, and then we'll calculate the proportion using that sum divided by the total population. So what that gives us is a handy dandy little table where we can see the number and percentage of the white, Black, and Hispanic population in Lamont. So we can see it's a very heavily Hispanic place. And so based on this, we might stop here and say, well, Lamont is 95% Hispanic. And so obviously Hispanic people are the most exposed to this contaminated water system. Yeah, Jeannie, I see you have your hand raised.
So, isn't that something you could just get just type in online and say, what's the percentage of Hispanic population in this block? And rather, I mean, because this is all pretty new to me, so I'm having a hard time following all the codes and the prompts and all that. So, my go-to would be just let's ask Google.
Yeah, for sure. So Google can do a decent job. I would be wary of it aggregating things from different sources and maybe like putting years together that shouldn't go together, that sort of thing. But there are definitely some like web-based tools that will let you look this up. So for example, that Census Reporter website that I shared with you. Ooh, uh, can I make it go? Let's see. No.
Yeah, I guess to put a finer point on my question, it's what are the benefits of doing it this way? Like, what are the yeah, why would somebody choose to do it this way? Is it more accurate? Is it more, can you I don't know,
Can I
control?
dive in on this one, Hannah? Yeah, that's a great question, Jeannie. I think if you're only asking one question of like, what's the population in Lamont by percentage, Google can give you a relatively justifiable answer. The reason for doing a reproducible analysis that utilizes trusted data is so that you can ask and answer multiple questions in different ways using all of the same stuff that you're putting together, and we'll show you what that can look like in the next parts. And as we saw at the beginning, folks have a lot of questions related to this topic, and so if you want to Google all of those things separately, there's concerns and issues with the robustness of AI in giving you those answers on Google, the who has the trusted data source, and even when we're talking about communicating the results, which will, spoilers for next time, by doing the analysis yourself, you get to determine the story you tell, how you communicate it, how you visualize the data, the colors that you use, the transparency, all of that stuff, which gives you more ability to communicate in a way that advances equity, whereas a simple Google search, you're stuck, if that helps.
Yeah, that helps a lot. Thanks.
Yeah.
Yeah, another thing I'll add too is that one benefit of doing it like in R or another programmatic way is it is reproducible and will stay reproducible so long as where you're pulling the data from stays online. If the Census API goes offline, I think we have bigger problems. But so we're pulling the 2020 data. Like if you typed in what is the like population of Lamont, you might be getting, if you're doing it in 2030, you might be getting the 2030 results instead of the 2020 results, and they may well have changed. And then like maybe the rest of your analysis doesn't make sense based on the things that have updated. We'll talk a little bit more about this in a few minutes, but it also can vary a lot between like the decennial census, which is a count, and the American Community Survey, which is run by the census, which are estimates that they calculate based on survey data every year in between the decennial census. So sometimes which source you use can be quite different. And so being able to like definitively say, I want the numbers from this census product can be really helpful and make sure that your analysis stays the same, no matter if it's run today or 10 years from now. But also to your end about looking stuff up online, the census has like a huge nested table like interface you can use to retrieve data in the browser. I will just give another plug to the Census Reporter folks. You can look things up by geography. So on the front page, I just typed in Lamont, and it pulls up a lot of really useful like demographic information and other information. So if you are just looking at one place, like this can be a really useful resource. And I certainly don't think, you don't have to learn to script to start answering some of these questions, but the scripting can kind of help you answer those questions at a scale that would be maybe impractical if you were doing it all by hand. But definitely encourage you to check out Census Reporter. You can see the age, you can see race, ethnicity, you can see economic indicators and things like that. And this is a really great resource. I use it all the time. Another thing I'll show you here too, to kind of replicate what we're doing in R, is you can get geospatial data from this website. I'm trying to remember how you can do it now. I'll have to share a link with you later, I suppose. Let's see. What is... Okay, we'll go with race. So yeah, okay, great. So that's how you get at it, is you can search a variable within that top bar, then you can go to like map. And then you can, this is sort of in the weeds, but you can set this up to get like census tracts and then download the data, which is a nice kind of alternate way. If you just need it for one place, you don't want to mess with R, you don't know R, this is an excellent resource. I'm glad you asked that question though. Thank you so much, Jeannie. Cool. Any other questions before we move on? Sweet. Well, we'll keep going. So this was our conclusion, right? So the population of Lamont is mostly Hispanic, so mostly Hispanic are exposed to this, and that's a problem, right? But thinking about how we went about doing this analysis, I wonder if you guys could think of like any assumptions that we're making explicitly or kind of implicitly in the way that we've approached this question that could be problematic. Anyone have any ideas?
You're assuming everybody lives in the city limits. What about everybody just outside of it?
Yeah, that's great.
One assumption, so maybe this is way off base, but I would think maybe you don't know all of the different ethnicities that live there, so you just search for Black, Hispanic, and white, right? So maybe there's Native American, Asian, Pacific Islanders.
We have another ad that everyone is on the same water system. What about domestic well users?
Yeah, these are all great. Any more before we go on? Cool. You guys were spot on. You folks were spot on. So there's a few here that I thought about putting this together. The first one is that using 2020 census data is an accurate reflection of the population of 2024. But these next ones are all ones you called out. So the demographic groups are representative of the entire population. As you pointed out, we only looked at white, Black, and Hispanic folks. There's a whole bunch of other groups that we didn't include. We're assuming everyone uses public water. That may not always be the case. And to your point about outside of city limits, we don't necessarily look at that in this. That's an excellent point, especially because Lamont and the Central Valley is like rural. And so folks are kind of dispersed. And if you read the press release, which we'll look at next week a little bit more, the water, it wasn't just like addressing the water system in Lamont, it was also consolidating like the water system and some of the surrounding, I think, unincorporated areas. So that was like a point that was considered too. But even just looking within the city limits, right? Like people don't, the population is not always mile for mile, like evenly distributed across the place, right? We have a downtown, we have sort of outskirts. So there are a lot of choices that we made that we should really challenge, see if they hold up. So that's what we're going to do in the back half of this. So we'll look at each of those 4 assumptions and kind of think about why did we do it the way that we did, and maybe what is a better way we could have done it. So the first one we'll talk about is the 2020 census data. And we talked a little bit about this already with the difference between the census and the ACS, but we'll kind of go into a little more detail here. So first reason for using the 2020 census data is that we can get the block level data. We can get the most granular data that's available. This is only available from the decennial census, so the counts. As the ACS estimates don't come at the block level. A reason for this is because of margin of error. So remember, ACS is estimates, And when you have a smaller population, you tend to have a larger margin of error. So they don't make blocks available at all for that and probably other reasons. But it's an important consideration to bear in mind. But say like we do want to try and use the ACS, you can get access to block groups, which are like the next smallest level of geography. But the population of Lamont is pretty small, right? And so with that same consideration of like smaller population, higher margin of error, the population of block groups can still be pretty small. And so estimates could still have our high margins of error. This is one thing I really actually like about the Census Reporter resource is that where there is a high margin of error, they call it out with these little like cross symbols. But that's always something to consider, whether you're using like the counts or the estimates, but especially the estimates, is to make sure you're accounting for margin and error in your results. Well, let me go back to our slides. So that's our first reason. We want the more granular geography, and we don't want to have to consider potentially high margin of error if we were to use the ACS estimates. The second one is that census data is a count while ACS data is an estimate. So just because the census data is a count, supposed to be a full enumeration of the population of the US, you know, there are groups that are more likely to be underrepresented. The Census Bureau calls these hard to count or historically undercounted populations, and they can include children, undocumented folks, unhoused folks, people, you know, that it would be difficult to get at like at a mailing address, right? But on the flip side, you know, if we were to use the estimates from the ACS, we have that large margin of error to contend with. So it's kind of like it's a trade-off. But I think based on this, like we're going to use what's probably the most precise, but it's important to bear in mind, and I highly recommend checking out this link about hard to count and historically undercounted populations to know kind of the caveats that the census data comes with, even though it's supposed to be, you know, the definitive count of people. So yeah, this is just remaking the point. Like these are all trade-offs, right? Like if it's 2029, maybe we're willing to deal with that higher margin of error to have data closer in proximity to like now versus using 9-year-old data. But maybe we still want that precision, right? So maybe we do still choose to use that 9-year-old data just so we can look at the block level. We want to think about, do we want that count or is the estimate okay? Who's not counted in a count? How can the estimates be imprecise? And which is the most tolerable? What is our analysis most tolerant of? And also more and less granular. So we talked about that before. Do we need the block level geography or can we handle, or can we work around a higher resolution? See a hand raised.
Yeah, go ahead, Ali.
Yeah, I might have missed and you explain it, but why is the reason that some years are more precise or granular and some years are not?
Yeah, so the decennial census and then the American Community Survey are kind of different like products that the census creates. So the census is every 10 years and it's an actual count. And then the ACS, they send out surveys to like a subgroup of people every year, and then they generate estimates based on that. And so those are less precise just by virtue of being estimates, but then also like response rate and like the population of the areas that they're generating the estimates for and how that changes over time can affect like how precise or like how wide the margins of error are like year over year. Does that answer your question?
I just want to flag someone else and added to the chat. Another consideration is to keep in mind that traditional data collection methods for 2020 census data were disrupted due to COVID. And so fact checking by going door to door was not possible. And then someone else asked, has anyone ever attempted to use some sort of model to transform ACS data to block level? acknowledging that that might result in larger margins of error, but just curious to see if that's something anyone has done.
That's a really good question. I actually don't know that, but I would encourage you to explore. And if you find something that looks promising, bring it next week and share with the groups. That would be cool.
And we've got a lot of like experienced data practitioners here. So one of them in the chat noted that EJ Screen does that and that there's a link to the mirror site in the chat.
Oh, amazing. We love it. Cool. So that's our blurb on just census data products. Now we're going to transition to that second assumption, which was correctly called out. Are we capturing everybody within the 3 demographic groups that we chose sort of arbitrarily? So as a reminder, here's what our result. And then this table is like the folks covered by our analysis, the total population in Lamont, and then we can see we were missing 182 people from our analysis, which, you know, you might say, oh, that's a small percentage of like 15,000 people, but it's still people. And I think that's one thing to always bear in mind is it can be really easy when you're working, you know, you really plug into the computer and you're like, I'm doing data. And like, you just start thinking in terms of like numbers. I think with this group in particular, this is not necessarily as much of a concern as, you know, talking with like pure tech like field folks, but these numbers represent people. You know, 182 people is probably like more people than you know individually. It's a lot of people. And so we want to make sure that we're covering everyone. And if we're looking at like a subset of the population, we're doing that for a reason. What we're going to do here is actually update our original analysis to include not only white, Black, and Hispanic populations, but all of the race ethnicity groups that the census gives us. And when we do that, we can see that we do in fact have other folks. So they're making up like a smaller proportion of the population, but for example, like we included the Black population, which is less than 1%. But we are missing like populations that are larger than that. So Asian population, American Indian, 2 or more races, which I'm like, you know, is a growing population in the US. So it's important to make sure we're counting everybody. Here's an updated version that adds up the number of folks in our analysis and the total population. So we've got everyone. Like I mentioned, it's really good practice to kind of start with everyone and then whittle down. Don't just start from the folks you'd pick off the top of your head. Like imagine if, you know, I guess this is also less of a concern with this group. You know, you're doing a lot of work in California that you're all very familiar with versus like I'm based in Chicago. So like I don't necessarily have all the context for a place for different like population dynamics in California. So it's especially important when you're working in geographies that maybe you don't know super well or not like, yeah, you don't know super well. But even when you do, like imagine you had omitted like the Asian population if you're looking at San Francisco, or if you're looking at the county level and you're excluding the tribal population, especially if you're looking at counties that contain reservation lands. It's also important to consider that ethnic groups are not like homogenous within them. So, you know, if there are distinctions that are like material to your question, so are we we want to look at the difference between like folks that identify as white or Black Hispanic? Do we want to look at specific subgroups of the Asian population or the Hispanic population? Is country of origin important? You can actually use census data to dive deeper into that. There are detailed tables for each of these groups where you can break that down further. It's also important, the table that we use kind of that lumps all 2 or more race respondents into one category. You can also delve deeper into like what is the composition of that mixed race population. But it's just important to know that. this can and should be responsive to the questions that you have. This is like a starting point, but you can drill down even further. And then the last thing I wanted to call out about this is that the census is changing the way that it collects race and ethnicity information. So it's combining the Hispanic origin and race ethnicity questions together. I guess some people were kind of confused that they were separate. I know it's definitely become a point of confusion for a lot of data practitioners. They're also importantly adding another racial ethnic category. So MENA, you might hear a Middle Eastern or North African, is going to be its own group. Now, like historically, these are sort of like folks encouraged to report as white, and so they're lumped in there. And if you want to get at this with older data, you kind of have to start with the white population and drill down. But this is going to become its own group, and there's a good PBS article here about the changes. But I included this here because I think it's nice when you're working with the data to see how it's actually collected. So like this slide shows what the updated race ethnicity question is going to look like, just for context. Let's see. Any final thoughts on that portion before we move on to our third assumption?
I think I'll just note that the trade-off comment is really important. Census data, ACS data, no data are perfect, right? But we got to start somewhere with something. And so really understanding the limitations. There are some additional limitations that are called out in the equity data handbook that were linked on the slide. Understanding the context of the limitations as you're going into the data analysis is important. That doesn't mean, oh, this data doesn't capture everything that I need in one go, so I'm just going to stop here because I can't do it the way I want to do it. It's really like taking it all in stride and making certain choices based on your question and equity principles and continuing to go despite those limitations.
Totally. And that's another reason too that I like working in a reproducible format, because like say you're working with ACS data, and then you have this other data source, that gives you an idea of the kind of, let's stick with race ethnicity since we're talking about it, but you have an idea of like the race and ethnicity of a particular population, and the ACS data is just kind of like really off from that. Maybe it's at like margin of errors, maybe collection, whatever, but it looks very different from like what like your other data source says. You could, if you have a reproducible like data pipeline setup, you could switch out the part where you're getting like the race ethnicity data from the ACS with getting it from the decennial census and kind of compare the results and see if what you get is closer to like the source of truth over here that you are relying on. But you can kind of tweak things like that if things don't go as you expect, or if you want to refine a lot more easily than having to like start over and doing everything by hand. That's not to say it's not possible. It's just easier. So yeah, Anna, thanks for raising that point. Cool. So now we will go into our third assumption, which also was called out. So that's right. There are private well users. To take a look at this, there's actually a really cool data set EPA put together that predicts like the probability that residents within a census block were using private well water or public water from a public utility. So on our next slide, that whole repository is linked down here. And then you can see in the R code, this is like the specific link to the data file from that repository that we're gonna use. But what we're gonna do is pull that down and see by census block where Lamont residents are most likely to be using public water versus a private well. So this first little block, I wanted to show you this because it can be really nice if you're like wanting to work on an analysis, like maybe on another computer, or you want to share it with somebody, but this is a large data file, and maybe you don't want to package that large data file with your analysis because like Outlook refuses to send a file that large. This code will check to see if you have the data file on your computer, and if you don't, then it conditionally like downloads it from GitHub. can be really convenient. This next line uses the reader package to read in its tab separated data. This also has like equivalent functions for reading in like CSV, reading Excel files. So know that those utilities are available to you in R, but this is just loading it into R so that we can do further analysis on it. And then we're taking that data that we made earlier, that is all the census blocks within the city, and we're merging, so joining in the block level probability of using public water with this merge call. And so what that is going to give us is, for all the blocks, the probability that a resident of that block is using public water. So this is kind of a truncated view of our results. We can see like the highest probability blocks, you know, almost everyone is likely to be using public water. But then you can also see, you know, we've got some blocks down here where it's like under 10% of folks are likely to be using public water. And this definitely goes toward the point that was made earlier about people outside of town, but also, you know, people in the outskirts of town, you know, may not be using the public water utility. So we can see it varies quite a bit. And we can actually update our analysis to account for that. So to illustrate kind of that variation in public water use, we'll make a map. It's called a choropleth. That basically means that we're going to color in the census blocks based on the probability that folks within that block are using public water, but you can shade the geographies based on whatever value you want. And it's a really quick and easy way to see like variation across space. And it's pretty useful. But actually, both of the mapping things we use today are really good for more imprecise illustrations of what's going on. They'll give you a sense of like how things are different, but you won't necessarily easily be able to say this is 33% chance and this is 75% chance, but you might be able to say, oh, this is probably twice as likely as this other adjacent block. So R has some really nice ways of making maps. We are going to use the ggplot2 library or package. And this is what an example call looks like. So to walk through this, anytime you want to make a chart, you start with ggplot, the ggplot function, and then we're going to add with the plus operator our various layers. So geom_sf is how you add a geographic layer to your plot. And we are going to add that data that we joined. So this is our block data with the probability for each block of using public water. And then to tell ggplot, we want to vary something about the geographies we're plotting. We use what's called an aesthetic. So, you know, yet another definition of aesthetic to go with the weird redefinition that TikTok has made. But aesthetics and ggplot are basically like kind of rules for how to conditionally format items on your map. So we're just telling it what field in our data represents a shape, and we're saying vary the fill based on the probability of public water use. That's what the column is called in our data. And then next, we have this, our ggplot has these great utilities based on Color Brewer. If you haven't used it, it's a super, it's web-based. If you search Color Brewer, it's a really nice resource for generating color scales for maps that are legible, but more importantly, accessible. So they're accessible to folks like with color blindness or other sort of like color perception variations. And it's just nice to not have to think about, so you can like outsource it. So you can come up with, you know, a scale, which is going to give you like a continuous range of values. You can specify like a particular color palette if you want. You can say like, I want it to go from highest to lowest instead of lowest to highest, that sort of thing. There's like a link to this, I think, in the footer. But that's what we're doing here, is basically saying from Color Brewer, give us like a friendly color palette that's a continuous scale from orange to red, basically. This next one adds a legend title. So it's labeling our color scale. So it's you know, when you're looking at this map, you can understand what the different colors mean. And then finally, we're just removing some of our like ticks, because it is like charting the geographic data on sort of like a plane. So if you don't remove the ticks, then it kind of shows up on an axis, and that's not always desirable. So this is sort of an aesthetic choice to remove those. And so what we get is a nice little map of Lamont. And we can see there's definitely a higher probability, upwards of 75, like bordering on 100%, higher probability of using public water kind of in the city center. And as you move out from the city center, it is getting lower. We've learned the probability of public water use, which is how folks would be exposed to the contaminated water, can very much vary by where someone lives. So this is where that fourth assumption we made comes in. Right now, we're treating everyone as if, they're sort of evenly distributed across Lamont, and so people are no more likely to be exposed to be using the public water. But we can actually update our analysis to account for the fact that public water use does vary. And to do that, we'll make some dot density maps. You've probably seen variations of these before, but for the newly initiated dot density map, basically takes a geographic shape and it has randomly placed dots within that shape that represent one or more people or like instances of an event inside that shape. So it's a great, like a choropleth, it's a great way to kind of approximate the distribution of something without really telling you, there's 50 people here and 10 people here. You'll just get a sense of like, oh, this is a more densely populated place than that. And then I also did want to underscore, so the dots themselves don't represent the actual location of a person. They're randomly placed within the containing geography. So for us, we're going to make a dot density map where there's dots representing 10 people within each block, and that'll kind of show us the population density within census blocks. So R, Trusty R has a nice package called dots that will generate this layer for you. So it'll take your like geospatial data and it'll give you back a layer of your randomly placed dots representing the variable that you want within each shape in your geography. So that's what we're doing here is we're basically passing in our city blocks. We're getting our, I think I picked population, this is arbitrary, but just to keep the code short, I picked the groups with population of more than 50 people. And then our divisor argument is how we say we want one dot to equal X. So divisor equals 10 is saying we want a dot for every 10 people in each census block. And then here, we're adding to the output like a column that has like a friendly label. Dots will give us back columns, like column values that are equal to like the column name, and these just kind of shorten that to a friendlier label. And now we're going to make our map. So one thing to point out is with ggplot, you can layer geographic things on top of each other. So rather than having our dots sort of floating in space without a lot of context for, where they are, we're going to use just a simple like gray base map that is the shape of Lamont to kind of ground them in space. And that's what we're doing here in our first lines 2 and 3. Then we're going to add our layer that is our dot density. And for this, we're going to vary the color of the dot based on what group it represents. Spoiler. Then we'll use another convenience color function. Another argument that you can use is like type. So before we had a continuous scale, if you specified type, you can have things that are like a scale, but qualitative is like these are categorical things, not like a number scale, and they'll give you shades of colors that are more distinct. So you don't have like pink or white, pink, red. You might have like green, yellow, purple. that sort of thing. And then again, we're just removing our axes. And so what this gives us is this map, which kind of looks like somebody spilled nerds on the counter. You can look at it and start to get a sense of like, oh, there's some variation in where people live, but especially because there's a lot of consolidation of people in the city center, I think we can do better and create maps that, as Anna kind of phrased it earlier, better tell our story of people are distributed differently across the city. So to do that, we'll make small multiples. If you haven't seen them before, a small multiple is essentially this same map repeated several times, and what is shown on that map varies. So in our case, we're going to create a version of our dot density map where there is like an instance of the map for each race or ethnic group that we're looking at. So we'll have 4 maps instead of just the one, and each map will just show one group. And this kind of lets you have like a glanceable way of comparing the way things are distributed on those maps, of starting to get a better understanding of how they're different than just having our nerds on the counter. So to do this, we're going to make a small change. So everything is the same except for lines 4 and 5. We are going to remove the aesthetic that we made that said color all of the groups differently, and we're going to replace it with this call to facet wrap, which is a function that comes with ggplot2, and it basically tells it, make a version of this for each of the values in the specified column. So in our case, we're going to make a version for each dot type column, which, if you remember, is that friendly label for like white, black, 2 or more races, or Asian. And what that gives us is a map that's a little bit easier to parse. So again, dot density, a little bit imprecise, but it does start to show you, there is some consolidation of folks in the city center, but for example, like white folks might be a little bit like more dispersed. So we can put a finer point on all of this by like squishing it together into a single analysis. So we know that public water use varies, and we know that where people live also varies. And so we can overlay the probability of water use with our dot density to start to get like an illustration of the different like proportions of the groups that are exposed to the contaminated water via public water use. So that's what we're doing here, making yet another map that is just a combination of the maps we made before. So we've swapped out our gray base layer with our choropleth map that we've made. And then on top of that, we're layering on our dot density layer here down in line 6. And what that gives us is a combined map of race and ethnicity and public water use in Lamont. We've got our labels are very important. I will definitely advise you to kind of think about them and make sure, A, think about them at all, but then B, kind of think about like what would be the easiest sort of language to parse for folks. So 1 dot equals 10 people, it's pretty straightforward. And then we've also got our probability of public water here on the side that tells you what the scale means. And then if you look at each version of our map, you can see kind of how people are distributed. So I think like the main difference that shows up to me is that like for Hispanic folks, for all of the populations, there's a lot of consolidation in this sort of like central block. But then if you look at the kind of lighter red block, just to the left of that central block, if we look at the Hispanic population, there's like a pretty big density there too, where the other groups don't necessarily seem to have that much, don't seem to live as often. So we can get more precise. Maps are great to illustrate, but tables can be a really excellent complement. to kind of give you a more precise answer and also really underscore the point that you're trying to make with your maps. So to make a table here, we'll use a handy summarize function that we used before to calculate some weighted averages, which will tell us like the proportion of each racial or ethnic group that's likely to be using the public water. This is really nice if you want to understand how different groups experience or expose to a condition, while also taking into account like where they are and how many of them there are across like a point in space. So this is the summarized college, just kind of walking through that. It's the same sort of syntax that we used before, where we're giving it the column name and then like the calculation to run, and then we're using weighted.mean from the R statch package, which gives you access to lots and lots of statistical treatments. So if you are doing statistical stuff, I highly recommend checking that out. And then also just calculating some of the like counts that we did before. So our result here is that we have a nice table summarizing the 4 groups we're looking at, and we can see not only like the number of folks that there are, but also the number of folks in that group that are likely to be using the public water system based on where they live, and then the overall proportion of folks in that group likely to be using the public water. So before our initial conclusion, right, was based on this like total population is mostly Hispanic, and so Hispanic people are most affected by this, and that's true. But what this extra layer does is it shows us not only that they're kind of more likely by virtue of being the majority population, but they're also disproportionately exposed. So while our other groups, you know, it's not an insignificant number of folks using the public water system. We're in the 70s. Hispanic population, you know, 92% of them are likely to be using the public water. And so that's quite a much higher proportion than the other groups. So basically, to wrap it all up, what we found is that people in the city center are more likely to be using the public water, and in Lamont, people who live in the city center are more likely to be Hispanic. And so we've not only found there's like a difference, but there's a disparity here that is interesting. So we're going to kind of wrap up here with some breakout rooms. I kind of want you all to reflect on what we found and how we got here. And then given what we found, what are some next steps you might think about taking? Some examples could be talking to people in the Mont. It could be, you know, identifying additional questions. It could be looking at existing programs and resources to address either the specific disparity that we found or failing water systems in general. There's a link here, which Anna, if you could drop that in the chat, would be super useful, to the handbook page that talks about kind of planning action with equity in mind. But what we're going to do is do 10-minute breakout groups. And then when we come back, we'll sort of wrap up by having everybody share back like some ideas of next steps you might pursue.
Yeah, so before I open the breakout rooms, I want folks to think about a couple things. One, pick a person from the group that's going to share a summary of your discussion. I recommend doing that first. Get that over with instead of doing it in the last 4 seconds before the breakout room closes. When you join your breakout room, it's going to flash your room number. Take a note of what breakout room number you're in. Before the room closes at 10 minutes, you'll get a 60-second warning, hopefully, if the settings are right. And when that pops up, you still have 60 seconds. So finish up your conversations and then join us, or just hang out in there and it should swoop you back in. Any questions before we get started? The rooms should have like 4 to 6 folks in them. Okay, I'm going to open the rooms. Hang on to your hats. We'll see you back here in 10 minutes. All right, welcome. So I'm going to ask that the room representatives, very fancy title, fancy title, can you raise your hand, like not in the recording, but with your reaction? And if you don't remember what room you're in, that's fine. I have all the secrets. But we're looking for 6 folks. 1, 2, 3, 4. We can figure the other ones out. And just a couple minutes, like 2 minutes of sharing your thoughts. Recommend if someone shared something specific to their personal experience, let's not share that, anonymize those conversations, and just share lessons or big themes that you take home from your group's conversation. All right, so let's start with Maddie. Do you want to share first?
Sure thing. I have no idea what group number I was in.
Great.
But we started by kind of recentering ourselves on the question at hand, or the issue at hand, which was that the public water had multiple contaminants in it that were, above threshold levels of a concern to health. And our group thought it was really important to connect with the Hispanic population that was the most affected, and a very large number of people, to first figure out how that water is being used. So is it a drinking water problem? Is it in swimming pools? Is it being used for agriculture? What mix of those? So that then when we look to the sources of the contamination, knowing that that'll take some time, we can also do education with the community of how to minimize exposure in the immediate term, and connect the community with resources, like maybe because this water's been contaminated for some period of time, people have already been exposed and need health resources that are safe for that community. And then ultimately making sure we have a plan to follow up after some technical work to remediate the contamination has been done, make sure that's effective.
Awesome. Thanks for sharing, Maddie. Let's go to Luke. Anything to add from your group?
Yeah, and I apologize. I don't know what my group.
I got your room numbers. Don't worry, folks.
Okay.
I got you covered.
Yeah, we kind of went back to the original research questions from the beginning of the presentation and saw where the analysis that was done in the meeting could be bolstered. So yeah, interviews with folks or talking to people in Lamont was definitely a next step that had to be taken to ensure that you had a sense of people's habits at home with regard to water use. It's kind of a necessary component to figure out routes of exposure, who's getting exposed. And we also discussed the use of CalEnviroScreen and how that tool could help bolster this analysis as well. So you can see where other types of contamination are in Lamont, and you can see that there might be potential routes of contamination discovered through that analysis, and also that would also provide some more context for looking at racial disparities in contamination exposure.
Thanks. Let's see. Jeannie, do you want to go next?
Yeah, sure. We very similar to what other people have said. We talked about how it would be important to get into the community and talk to community groups and find out what other languages are spoken in that area, so that we can make sure that communications are delivered in all the languages that need to be used. And then, we would make sure we had a good way to communicate status updates on the updates or the progress of the drinking water plant updates. Also to communicate alerts. So anything that, happens during the update to the treatment system. We would also focus on the public health impacts from the contaminants that people may have ingested. And so, we would look at the chemicals that have been found and what kind of long-term health effects might occur. And we'd want to make sure there was some kind of program set up for monitoring long-term health impacts, maybe set up a fund to help with healthcare expenses. We thought it would be really cool to hire someone to work in the community, like have an office that people could go to and talk to someone, face to face. Maybe put a division of drinking water office in Lamont, or just have a little space for people to go talk to a person. And those were our thoughts.
Awesome. Thanks so much. Selena, do you want to go next?
Sure, if I can find my audio button.
You're there. You're good.
Yeah, much like Jeannie, we had also discussed kind of language access and potential, outreach perspectives to prepare to go before going out there. To not repeat what we've already heard, I think one topic that came up that I haven't heard yet was of the non-public water users. What does that water quality data look like? Could we potentially bring in some Sigma data to look at groundwater contaminants? Is that, was that data surface water? So the arsenic and 123 TCP, what type of data was that? And how does it compare to other kinds of available data? Another aspect we discussed was identifying the sources of contamination. Are they ag? You would assume in that area, but yeah, source identification. Also, safer program users, of that percent of people who have their water quality impacted, do they have access to clean drinking water? Are they utilizing, self-help? I think there was a new update to DDW's webpage. They had a cool website with interactive map and data available. I've been kind of searching and playing around there. So is that something we can kind of bring into our and potentially overlay with available census data? So
nice. Thanks, Selena. Stephen?
Hey, so pretty much mirroring a lot of what I've heard already. What we came up with was very similar, where we would follow up with like local specialized groups. So it could be, maybe some regional board, someone who's located in the area, and also external stakeholders, as some discussion may lead to further questions or items that were not considered originally that may be relevant going forward. So we didn't go really into specifics, but kind of high level. That's what we would go to in terms of next steps and researching before we go to the public.
Great.
Thanks, Hannah.
Thanks. Tanya, take us home.
Great. Yeah, I think the first step that we discussed was take a look at the Human Right to Water failing list that is published by the Division of Drinking Water within a quarterly basis, because that will show if Lamont has a repeated history of compliance issues. And of course, if it is in the failing list, that says a lot. And if it is, we will reach out to SAFER staff, because they might already be aware of this, of Lamont being a priority, and perhaps there is a project already ongoing. If there is not a project ongoing, we will reach out. We will determine if this is a small, if Lamont is serving a small disadvantaged community, and we can do that by going into the 2023 American Community Census Survey to determine what is the median household income of this community. And then after that, we will reach out to the Lamont Public Utility District representatives and make sure they are aware of the situation and how willing are they to participate and kind of move forward with the project. If they are, the next step will be to reach out to our board of directors, because they always need approval from their directors to move forward with any project. And some other things to consider, which, well, within the next step will be, if the board of directors approve that project to move forward, will be to maybe request through DFA the assistance of a technical assistance provider through a technical assistant request application, so that through the nonprofit organization or technical assistance provider, we can gather information. We can do outreach to the community and gather information on their demographics. So clear flow of information can be provided in multiple languages needed, and also determine what level of exposure the community has been through, and determine if there is a immediate need for an interim solution such as bottled water, while the permanent solution is in the works. And yeah, that's all what I have.
Fantastic.
Thank you.
Those were so many great next steps that everyone shared. And I think too, I heard a lot of like additional data sources or resources to consider. If y'all can grab those easily and add them to the chat. One thing that I would like to do is for links that aren't already included in the slides, I want to work with Hannah to add another slide after the close of resources that we shared together through the chat, since as soon as we all leave, the chat's going to disappear, right? So we can embed those to the slides, which, fun fact, these slides were also made using R and GitHub. So updating them will be very easy. And the link that you have will show the updates as soon as Hannah is able to push those through. Any reflections, Hannah, that you want to share before we go to the next part?
Yeah, I just want to remark that I all of the responses really make me feel like we're in a good spot to move on to module 2 next week, when we will start to look at some additional data sources and really start to dig into why what's going on is going on. And I was also so happy and not surprised to hear how many plans really started with outreach. Because like I mentioned before, data isn't people, it represents people. And data doesn't always capture a full lived experience, for example, like this is like a practical thing, but we looked at probability of water use, like source, like where you live. But people don't just stay in their house, right? Like, what about where they work? What about where they recreate? Is the public swimming pool, on the public water source? And everybody who's swum there has been exposed to that sort of thing. You wouldn't necessarily get that from data, but those are the kinds of perspectives that you're really going to capture by actually talking to people and hearing about how they live. So I loved to hear that from, I think, every group. That was awesome. And yeah, I was really excited by all the responses and not at all surprised based on the group. So thank you everybody for being so thoughtful and for being so generous too and sharing what you all talked about.
Yeah, so just to respond to the chat that just came in, I'm not going to share the chat with you because it looks gross. We're going to reformat the resources and wisdom that you all shared together in the chat, and we'll add them to the slides. So everyone will have access to them at a later date, and we'll resend the slides through email. The link that you have will be updated, so it'll be fine. Just believe me when I tell you this. We do have some time. We've got about 15 minutes before the session closed, so I want to invite folks, if you have questions about anything we covered so far, or, burning points that you wanted to share from the breakout rooms, welcome folks to elevate those. Now we can go back to certain slides, dive deeper into different components of the conversation. If you need to jump and prepare for the next thing, do so without guilt. We'll see you next week. And I'll be sure to send a link to next week's slides before the start of the session so everyone has access. Yeah, Jeannie.
Yeah, how do you recommend becoming more familiar with R and how it works? I mean, do you have any, are there any online trainings or free trainings or even, how do you just get
Yes.
comfortable using it?
Yeah. I was saying to Hannah during the break, and I'm going to repeat now for the recording, I feel like, Jeannie, we are paying you for your questions because they're so on point. But we
I am
aren't,
on the clock, so.
The water boards hosted a series of trainings for R. I'm going to add a link to the chat, R for Water Resources Data Science. There's an introductory course and an intermediate course. Like this, all of the content is available online. And I think the Training Academy is trying to offer these again if you are a live training type of person, or rather than I want my own silence and just kind of walk through things together. I also recommend, if you aren't already a part, I think you all are, but the equity data, the Environmental Justice Roundtable's Equity Data Subcommittee. That's, I think, where y'all heard about this. So you're probably all part of it. For those on the internets that are seeing this after the fact, tap into that community and find partners, friends. There's also in the Microsoft Teams space, there's, I can't remember the name of the team. What's it called? The Waterboards data community. So if you're like deep in the code and you hit an issue, you can plop something into the chat and be like, help, what does this error mean? Does anyone have a second? And people are pretty good about chiming in when they have time. And now I'm rambling, but if other folks have thoughts to Jeannie's question, I think the other thing too is to acknowledge that using programming languages like R and Python, it takes some investment in time and, in my experience, tears and pain just to like build the muscles to do the coding. You're literally learning a brand new language. And so be patient with yourself and lean on community and resources and the internets to find things. But once you kind of build those muscles, it gets easier over time. Anyone else have thoughts on that? Yeah, Luke, I see you unmuted. Do you have something to add?
Yeah, Jeannie, I would say like half the battle is figuring out what what question you need to ask to get the code that you need. That's like most of it. So then like basically just finding something that you can Google or ask somebody else. And I would throw another resource in there, like ChatGPT or another AI, that can like check your work for you. You can like literally copy and paste your script into the chat bot, and it could either like pick out an error, or you can ask it to create a script for you, and you could ask why, like for an explanation, like why it did what it did. So I would use it as a tool, but yeah, it's a really good coder.
Yeah, I definitely agree. Like, I'll kind of point or glom on to Anna's point. Like, first of all, I think like the number one thing you can do is like do some things on your own, but really like talking to somebody else about what you're trying to do can be very helpful for exactly the point that Luke made, which is that half the battle is really figuring out like what is the vocabulary I need to use to get the answers I need from Google or from ChatGPT. And so to that end, like talking to people is great practice, but also that's what makes something like ChatGPT so useful is you can talk in like regular language to it and it can help you. You can say things like, I'm trying to do this thing. Is there like a term for like this kind of analysis, or like what functions, like if I want to use the tidyverse, like what are the functions that can help me do X, Y, and Z? And I feel like it's a little bit more forgiving and also instructive when you're trying to build that vocabulary than maybe going straight to Google sometimes. So use with discretion, but it can also be used, as a tool. So I'm going to do it for you, but it can definitely serve as sort of like another sort of like person, albeit artificial, who's kind of in your learning cohort.
And in the data science space, talking things out, like literally out loud, is known as rubber ducking. Like data nerds sometimes have like a rubber ducky on their desk and they're trying to debug something. So they talk the problem out to the duck if they don't have a person with them, right? But like, talking things through with a rubber ducky, or I have a little squid because that's my jam, or people on your team or in the community. That's part of the process, that I hope we can normalize and stay connected. There's a lot of things going on in the chat. I recommend, does someone have a question they want to elevate that they added? I see a lot of resources that we'll share.
Maddie had a question that I do not know the answer to.
Great. Let's see if we know together.
It's thinking. I tried adjusting the well data file path a bit, and that might be helping half my issue, but it might still be struggling to download. I don't know. But I always have trouble with the download file. Like I've had this problem in other trainings too. And so I thought maybe it was like a state computer issue or something like blocking stuff, but I'm still messing with it. So unless someone immediately was like, oh yeah, I always have this problem on a state computer and this is what I do, then I'll just keep clicking. Thank you though.
Yeah. File paths can be cranky. Another package that we didn't talk about is the here package, which can make all of that simpler. It's a piece that is even better when you use R projects. Those things are also described in the R Forwards introductory course. But has anyone found the solution to the downloads issue that Maddie described? I have found in certain cases that, like if you're connected to VPN or on the network, some things like that get cranky. So try it off of those things. And then Bobby, I see you unmuted. Do you have something to share?
Oh, I was just gonna share. I ran into the same issue, but feel like it's probably a problem on my end. I think it's probably not looking in the right spot at the moment. So I was gonna play around with that and see if I can possibly make it happy. But that's why usually my personal preference, I like working in the R project space because then I don't have to worry about the file path as much. It's all just in one place. And that's been my workaround for a long time.
Totally. And I think too, Anna, the point you made, the here library is super good, and it like is made specifically to solve this problem. So I think if I'm remembering the code correctly, I think I did like a relative path to the data with like the dot to go up a directory and then back to the raw data file. But if you change that line to use the here package and then like form that file path, like absolutely, instead of relative to where things are, like that might be interpreted differently based on how you're running the script. That should help, but I can also look into it on my end as well and push a revision that fixes it if folks don't have time to tinker with file paths, which is one of the more annoying parts of programming, I feel like.
Yeah, I just added a link to the chat. It's module 3 in the introductory course for R Forwards, and it literally walks through all of the things that we've talked about. So it talks about our projects. It talks about a recommended like file system that you might use for your project management, doing data analysis, talks about the HERE package, things like that. So if you're wanting to dive into those components more, if you haven't already been introduced to those concepts, that's a great place to start. Any other? Thanks. Thanks for the thumbs up. Yeah, Tina.
Hannah, great training. Thank you. I was just going to share something like that kind of stuck out to me in the breakout room is like we all work for the water board, but we're in different programs. And so we had like this question, but the way I looked at it was slightly different than like my other friends in the group. And so just the importance of having like that cross program, the diversity with all of us and those lenses to come up with like our plans, our projects, and our solutions, and how valuable that is to have all of that in like a space. And it was just really neat to like hear from others. And I was like, oh, I hadn't even thought of that. So just thank you for like getting us all together and like getting, yeah, it was really cool. That stuck out to me. So just wanted to share. Thank you.
Thanks, Tina. Yeah, and I think that really underscores the importance of collaborating internally, of finding solutions or questions together, but then to what everyone shared after the breakout rooms of there's more benefit of finding partners outside of the water boards for additional lenses and expertise that we maybe don't have from the lived experience side of things, which is the importance of partnering with community partners, tribal governments, other agencies, right? It all depends on the questions that we're asking, but really to like elevate and amplify the benefit of what you just shared, Tina. There's awesome to collaborate with ourselves. We could do more of that better, but we can go even further too. And hopefully the Equity Data Handbook is a resource to help you get started from the data lens, but there's lots of other resources out there that we link to in that as well. All right, last 5 minutes. Any burning questions? Otherwise, have a delightful week. We'll see you same time, same place next week. And we're looking forward to it. If you have any feedback, in the meantime, some things that I heard was, Anna, send the slides before the freaking training, girl. I got that. I'll do it. I promise. It'll be an email. But if you want to send feedback on like the speeds that we went through things, the resources that were available, if we can modify and adapt, Hannah and I will work together to do that before the next training. I will invite you to add things to the chat. You can share it with everyone. You can message just me. You can send me an email after the fact if it's a constructive piece of criticism that you want me to anonymize before sharing with Hannah. We can work around all of that too. All right.
Thank you. Have a good day.
Thanks, y'all.
Thank you, everybody.
Take good care.
Thank
See you
you.
next week.
See you next week.
Thanks. Bye.
Thank you.